Okay, the second profit problem that we worked on together in class was the situation in which now Otto makes only $1 profit on cars, but his profit on trucks has doubled up to $2 per truck. And let's construct ourselves a profit equation. What I encourage you to do is pause the video, try and construct your profit equation, and then when you're done, hit play and compare your work against my work. That's going to be the best for your learning. Let's get into it. What we know is that to make a profit equation, we have to take good notes. So, cars, we make $1 profit on cars. And again, we know that the variable associated with cars is X in this scenario. Trucks, we make $2 profit on trucks this time. And our variable is Y. And here's our notes that we're going to refer to when we make our profit equation. And in this class, remember, every profit equation begins P of XY equals the profit on cars and trucks is, well, we said last time, $1 for every car is 1 times X. $2 profit on every truck is $2 times Y, and the total profit is the sum of those $2 values. So our profit equation is P of XY equals $1 times X plus $2 times Y, and we're good to move into testing our points. We're working with the same 5 candidate points, and that's because those are our intersections of our system of equations, our smallest y-intercept, our smallest x-intercept, and the point 0, 0. So let's begin to substitute. I'm going to start with the top of the list this time, 0, 0. So our equation, P of xy equals $1 times X plus $2 times Y. And the point that we're using is 0, 0, which corresponds with 0 cars and 0 trucks. Let's substitute this. P of 0, 0 equals $1 times 0 plus $2 times 0. And now that we're done with our substitution, we can start to simplify. Again, I rewrite that same work below. Let me break this up visually for us. I think that looks a little nicer. We start with our same work as the previous line. And now, 0 times $1 is $0. 0 times $2 is $0. And no money plus no money, if I got nothing and I get nothing, I still have nothing. That's $0. So we know the profit when Otto doesn't make anything is $0. And that makes sense with reality, right? If you don't make anything to sell, you can't sell anything, you can't make any money. Pause if you need to. I'm going to get into our second point here, 0, 5. So I want to save us both a little bit of time here. We're talking about 0 cars and 5 trucks. And so I did that substitution independently. I hope that you're able to do the substitution independently as well. If not, talk to me and we'll keep talking about substitution because it's very important. All right, let's start to simplify 0, 5 in our equation. Let me paste this. Okay. So, just like before, $1 times 0 is $0. $2 times 5, 2, 4, 6, 8, $10. And if we have no money, and then we get 10 bucks, in total we have 10 bucks. So our profit when we make 0 cars and 5 trucks is $10. I'm going to do the rest of this work mentally. If you can follow along with me, follow along with me. But if you really want that practice, which I think is good practice, substitute and simplify each of our remaining combinations into our equation here. Okay, so that's 8 plus 3 is 11. 4 plus 6 is 10. And 7 plus 0 is 7. And just like we saw before, when we had our graph and our grid with all of our points, the maximum profit in the case where Otto makes $2 on a truck and $1 on a car is $11 when he makes 3 cars and 4 trucks. And so to sum everything up, our profit equations make finding our optimal solutions easy peasy. Constrained optimization is all about making the best use of your limited resources. And in this case, the best use of Otto's limited resources is to make 3 cars and 4 trucks. And he'll have some materials left over, but that's okay because he couldn't make any more money with those materials anyway. Along the same vein, like in this scenario, the best use of Otto's limited resources is to make 6 cars and 2 trucks to earn $8. And again, he'll have materials left over, but that's just the way it goes. He can't make money on those materials, so he shouldn't worry about them. In closing, I guess, I don't know, constrained optimization is super important because I almost guarantee it. In fact, I do guarantee it. You will encounter some situation in your life where you have to use constrained optimization. And if you don't have a good understanding of this, you won't make your best decisions. And we always want to make our best decisions, right? So watch these videos again if you need to. Do the associated work with our constrained optimization problems. And have a nice day. Bye.